All right, everybody. How are you guys? Wait a second, am I live? Not yet. I think I'm live, isn't it? Yes, I am. I can see myself. All right, everybody. As I always say, Andariki Namaskaram, Ellargu Swagatam, and a very warm welcome to Vedantu JE English channel. This is me, your master teacher Nabamita Ma'am, and today, after a very long time, we are going to study chemistry because yesterday Nabamita Ma'am had switched her job to become an English teacher. Today, however, I'm back to my old self and I am your chemistry teacher, guys. So yes, how are you all? How are you all? Where is the link for highlighted important lines? Karthik, is it not there? Don't worry about it. I will tell the channel manager, that is Pradeep. Pradeep sir will definitely add the session links also below this video. Don't worry about it. So quickly guys, tell me, how was your English exam and did you guys get the writing section? Did you guys get the notice writing, job application, letter to editor, and what was it? What all the things that I taught you, right? I taught you all of these, isn't it? So how was it? Were you able to answer all of these, guys? Yes. Where is the link for Karthik? Like I said, I'll do that. Ma'am, put live with concepts and PYQs compound. Of course. Tomorrow when I'm taking the marathon, I will be doing concepts as well as PYQ. Of course. That is what I told you in the session. How to get line by line explanation. Line by line explanation we had done already. Can you please check it out? Okay, what is the timing for tomorrow's class? Tomorrow, the first session will happen at 12 p.m. and the second session will happen at around 5:30 or 6 o'clock. Okay, that I'll have to tell you later. English exam was a lot easy. Okay, all right, yes. Very easy. Common start the session, ma'am. Of course, yeah. What? You have to have a common session, a common start. Doesn't Shreyas sir do like this? Yeah, so I have my this thing. Yes, Nandini ma'am is your Durgesh ma'am. Absolutely right. Yes. Done bad in literature. Why? Literature was the easiest, yeah. Last year board exam, yes, we will do that also. Don't worry about it. Don't worry about it. Yes. Hi Divakar, how are you? All of it, you will get it. Chalo. Alright guys, so today, now we are going to do all the formulas of the physical chemistry. That is, there are 3 chapters in physical chemistry, everybody. In your class 12 boards, you have only 3 chapters from physical chemistry, which is solutions, electrochemistry, and chemical kinetics. So your job becomes a lot easier than JEE Mains, isn't it? In JEE Mains, we also had to do thermodynamics and chemical equilibrium and atomic structure and chemical bonding, but here there are only 3 chapters, which we are going to finish it very, very, very fast, everybody. So I hope that you all are sitting with a paper and a pen. Any which ways, I am going to give you the, I am going to be giving you the PDF, not to worry about it. However, it is still going to be better if you sit with a pen and paper. All right. Yes. So shall we start, everybody? Are we here? Are we here? Yes. I will. Raghavan, I will definitely. Yes. I am good, Saujanya. I am good. Yes. Smiling smile, it should be fine. So chalo, let us start with the solutions chapter, guys. I'm going to talk a little less because we need to study right now, isn't it? So, well, we are starting with the solution chapter. In the solution chapter, guys, this is a quick recap of the mole concept session. The mole concept chapter, if you know, concentration of solution, how do we find out? Initially, what do we do is, first we go for percentage weight by weight. That's the first formula. Percentage weight by weight is the first formula. And what is the definition? The definition is mass of solute in grams present in 100 grams of solution, guys. What is the formula? You write it as percentage W by W is equal to mass of solute divided by mass of solution. And because there is percentage here, as you see, you have to multiply it with 100. Make sense or nonsense, everybody? This is easy peasy biryani. Tasty? Are Baba, coordination, compound and all, everything I'll do it tomorrow. Don't worry. Tomorrow we will do inorganic chemistry. We will start with inorganic. Don't worry. Yes, is this clear, guys? This is easy peasy biryani, tasty, isn't it? Great. Okay. Secondly, what do we have? We have percentage weight by volume here. So that means that our definition is going to be mass of solute in grams present in 100 milliliter of solution. Make a note, 100 milliliter of solution here. Percentage weight by weight had 100 grams of solute. 100 grams of solution here, 100 grams of 100 milliliter of solution here. So how do you write the formula? You write the formula as percentage W by V is equal to mass of solute divided by volume of solution multiplied with 100. Yes, once again, easy peasy biryani, tasty. Very good. Baba, PDF. How do I give you to write now? I have to write it. No, then we have to convert the PDF, right? If I don't write it, can I give you the empty slides? No. There are certain formulas that I'm going to write it and explain it to you. Okay? Chill. I'll give it to you. Don't worry. As soon as the session gets over, you will get the PDF in the description box as soon as I'm done with the session. Don't worry about it, and you will also get it in Telegram channel. Chill Mari, chill Mari. Ma'am is here, Vedantu is here, why to fear? Huh? Chill, no, I will give you PDF. Yes, this exact same PDF you will get it. Exact this PDF you will get it after the session. Let me take the session, Babu. Hey, everybody, focus up. Look at me, look at me, look at me. You guys are not listening to me. Everybody look at me and listen to me. What I'm trying to tell you is that there are certain, okay, Saujanya, smiling smile, Sru Krishna, Shakti, Shri, Attachaya Kumar, Ram Kumar, Yashwant Ram. Everybody, listen to me guys. Eyes up right here. I'm going to give you the PDF in the Telegram channel as well as in this video, below this video description box. But I will be giving you exactly this PDF. However, there are certain empty slides. Do you see? These are empty slides where I'm going to write the formula, explain it to you, and then I'm going to give it to you. If I give it to you now, the slides are going to be empty. Is that okay with you? I hope no, right? I suppose no. Can I give you the empty slides? Not at all. So I'll be giving you the PDF once I'm done filling up these slides. Okay? Alright. Now guys, moving on to percentage volume by volume. How do you write it? The definition is volume of solute present in 100 milliliter of solution. And the formula is going to be here. Percentage volume by volume is equal to volume of solute divided by volume of solution into 100. Okay? Alright guys. Now, let us take a look at mole fraction. Mole fraction, what is mole fraction everybody? The ratio of number of moles of a particular component. Component bole to here solute most of the time. Okay? So particular component in the total number of moles of the solution. How do we denote it? We denote it as chi of A. Let's suppose that A is a component, A and B. Let's say that in a solution, you have certain amount of sugar. Let's call the sugar to be component A and the water to be component B. So here, let's suppose that we want to find the mole fraction of the sugar. Then what do? We will write it as chi of A is equal to N of A, that is number of moles of A divided by total number of moles of the solution, that is Na plus Nb plus Nc. Getting it? Very good. Next, okay. Here if you see, now sum of all the mole fractions of the component that are present in a solution, it is supposed to be 1 because it's a fraction, right? And in mathematics in your younger days, you must have you must have learned that 1 by 2 plus 1 by 2 is equal to 1. 1 by 3 plus 1 by 3 plus 1 by 3 is supposed to be equal to 1, right? 1 by 4 plus, whatever. The fractions are supposed to be equal to 1. The sum of the fractions are supposed to be 1. So this is what it is, okay? Now we come to parts per million. What is parts per million? Very similar formula as percentage weight by weight. However, instead of 100, you will write here 10 to the power 6 because it's million. Yes, because it's million. So the number of parts of the solute that is present in every 1 million parts of the solution. That is your parts per million. Now what is the formula? The formula is parts per million is equal to number of the parts of the component divided by total number of parts of all component of the solution multiplied with 10 to the power 6, guys. 10 to the power 6. Now, by chance, in case of percentage concentration in parts per million, it can also be expressed as mass to mass, volume to volume, and mass to volume. Got it? And finally, we come across concentration of solution, that is molarity and molality. Guys, if there is molarity and molality, which one will you prefer more? You should prefer molality because molality is independent of temperature. Molarity, however, depends on temperature, which is why molality is preferred more. However, what is the formula for molarity, guys? Number of moles of solute present in 1 liter of solution. That is your molarity. Molarity is denoted by capital M. Capital M is molarity, which is equal to moles of solute divided by volume of solution in liter. And like I have just told you that molarity is a temperature dependent quantity. But molality here is temperature independent quantity, everybody. And how do you write molality? Molality is denoted with small letter m. Okay, small letter m, which is equal to moles of solute divided by mass of solvent in kg. All right. Now we all know that volume is dependent on temperature, isn't it? If I heat up a little bit of water, what will happen? It will start changing into, it will start getting converted into gaseous state. And in gaseous state, obviously the volume will be more. But in case of mass of solvent, tell me something, do you think that it will be dependent on temperature? Not at all. Hence, mass of solvent in kg, molality is not dependent on temperature. Is this clear, everybody? Is this clear, guys? Is this clear? Yes. Now finally, now in your exam, let's say that molarity is given to you, you have to calculate normality. How will you do it? If molarity is given to you, you have to calculate normality, guys. Then capital M is equal to N. Okay, this is not here, guys. This is not clearly mentioned here. Okay, let me tell you. See, from here we can derive it. See, capital N is equal to capital M multiplied with small letter n, right? If normality is given to you and you have to convert it to molarity, then normality is equal to molarity multiplied with n. Now, if molarity is given to you, correct? If molarity is given to you, what will you do? Molarity will be capital N divided by N, isn't it? So here it will be divided. This is how you convert it, okay? This is your conversion. This is how you are supposed to convert it. Now, if molarity is given to you and you have to convert it to molality, then what do? You write a small letter m is equal to capital M multiplied with 1000 divided by rho multiplied with 1000 minus capital M multiplied with m2. And here all the explanation of the terms are given, guys. Capital N is normality. Capital M here is molarity. Small letter m here is, small letter m, my dear student, is your molality. Rho is density. Capital M1 is your molecular weight of solute. Capital M2 is the molecular weight of the solvent here. Chi1 is mole fraction of solute and Chi2 is the mole fraction of solvent, everybody. Yes, N, small letter n is number of moles. Yes, small letter n is number of moles, guys. Come on. I thought you should know it. I thought you will know it. Yes, that is why. Pranav, yes, small letter n is number of moles. Very good. Okay. So this is basically, this is the diagram here which you need to look at, everybody, and you will be able to convert them. Okay? Now if molarity is given and you have to calculate mole fraction, then this is the formula. And if mole fraction is given, you have to calculate molarity, then this is the formula. All right? These are the formulas here. All right, everybody? Yes. Okay, guys, I see a lot of chat. Can you guys focus up here? I do not think that you guys are... What is small n? Are Baba just told you number of moles. What is small n? You don't know. I don't know. Really? Huh? I don't know. Really? Huh? Really? Without studying anything, without completing my class 12th, I'm here and teaching you. Yes, guys, why are you guys talking so much? Can you tell me? Can you tell me? Why are you guys talking so much? Why are you guys talking so much, everybody? Focus up, no? Focus up. Focus up, everybody. Focus up. Vinaya, you will be. Can you please stay? Stay now. Esther, why right now, Bachu? Why right now? Wait up, I will tell you. I will tell you all of it. Please don't do this, no? Why are you doing this to yourself? Just like that, you are taking your own stress by yourself. Nobody is asking you to stress. Are Baba, NCRT line by line, whatever, all of it you will get. No. Chill. So much of disturbances in the class. Ye dekho, again. I will give you, Baba. How many times will you ask me the same thing? Ma'am, PDF, ma'am, PDF, ma'am, PDF. I told you, I will give it to you. I will give it to you. Don't worry about it. I will give it to you. Okay? Yes, I will. I definitely will. Don't worry. Yes. If you cannot find NCERT line by line, no worries. We will re-upload it. Okay? We will re-upload it. Chill. You will get it all. Okay? No, calculator is not allowed. Okay. Once again, everybody, see. Normality and molarity. If you are given molarity and if you are asked about normality, then what do you do? The formula that you will be using is this. Capital M is equal to normality divided by number of moles. N, this small letter N, my dear student, is number of moles. Okay? Yes. Now, if you are given normality and you have to convert it to molarity, then you will use the formula capital N is equal to molarity multiplied with number of moles. Okay? Alright everybody, if you are given molarity, you have to calculate molality. Then this is the formula you use. If you are given molality, you have to convert it to molarity. Then this is the formula you use. If molarity is given, you have to convert to mole fraction. Then this is the formula. If mole fraction is given, you have to calculate molality. This is the formula. Alright everybody, is this clear? Is this clear everybody? Great. Now moving on everybody. Now we come across the actual part of this chapter everybody, which is your Henry's law. In the solutions chapter, let us start with Henry's law everyone. Yes, what does Henry's law tell you? Henry's law everybody tells us that the solubility of a gas, everyone writing it down, write it with me. The solubility of a gas, okay, of a gas in a liquid, is directly proportional to the partial, okay, yes, to the partial pressure of the gas, okay, partial pressure of the gas above the surface of solution, above the surface of solution. Tell me something, read this line everybody and let me know, is this Henry's law that you have studied? This is the Henry's law that you have studied? Yes, this is the Henry's law that you have studied. एक काम करते हैं, everybody, let us do one thing. Yes, everybody, let us do one thing. Yes, Shrivat said, go ahead. Spam, bacha, spam. Spam as much as you want. Once you are done with the spamming, then let me know. I will start with the session. Spam, spam, spam. Get done with your spamming. Yes. Get done with your spamming. Yes. NCERT line by line PDF not available. How many times do I have to tell you? Do you see 10 hands here? Do you see 10 hands here? No. Right now, what am I doing? I am live here taking a session. So, do you want me to give you the PDF right away? How will I do that, bacha? Right now, I'm taking a session. Let me take the session. I'll give you the PDF, Baba. I will give you the PDF. It's here. I'll give it to you in the Telegram channel. The fill in the blanks that we took it, right? I'll give it to you. Don't worry. Okay? I'll give it to you. All the PDF that you want, I'll give it to you after this session, but. Okay? Okay? Alright. Thank you so much. Now can we please study the formula sheet also? You will get it after the session. Right now, please be with me. Focus up. You will lose. Otherwise, you will lose. Okay? No worries. Take it. I'll give it to you. Don't worry about it. I'll give it to you. So, Henry's law, everybody, read the sentence. Please read the sentence and let me know this is making sense to you or not. Yes? Triyambikam, Pitti, you will get virtual punch. I've told you how to find normality. What are you doing? Huh? I've told you how to calculate normality. Just now only I've given you the formula. Guys, it looks like in chemistry exam, you will definitely remember my face. Everybody, shh, shh. You are in a session, right? In a session, no? Keep your mind blank. Keep your mind blank. Forget about everything else that you did not know. Let's focus on what we are about to know now. Can we do that? Please, can we do that, everybody? Focus up, please. Shh, 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 shh. You will get everything. You will understand everything. There is still 4 more days. Leave it up to me. We will do all of it. Don't worry. Right now, please focus on this session. Please. Please. My dear bachus, please. Yes? Shall we do it? Shall we do it? Yeah? Let's do it? Okay. Alright. Chalo. Now, guys, moving ahead, everybody. Yes. So, the Henry's law, it states that the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas above the surface of solution. This is your Henry's law. And how do we express it mathematically? Mathematically, guys, we express it as P is equal to KH chi B. Right, everybody? Where P is your partial pressure. Yes, P is the partial pressure of gas in liquid. Yes, of gas in liquid, my bachus, right? What is chi? Chi, my dear students, is the mole fraction of gas. What is it? Mole fraction of gas in liquid, isn't it? And what is K? K here, my dear student, is your Henry's constant. All right. So according to the question, if they are asking you about Henry's law, then this is the one that you are going to write. All right. Now let us go to Raoult's law, everybody. Raoult's law is also very, very, very important. Let us have a look at it, everybody. Raoult's law. Yes. For a solution of volatile liquids, the partial vapor pressure of each component is directly proportional to its mole fraction in solution. What is Raoult's law? Raoult's law suggests that for a solution of volatile liquids, yes, for a solution of volatile liquids, the partial vapor pressure of each component is directly proportional to its mole fraction in solution. Am I right? Am I right? This is your Raoult's law, everybody. So how do you write? How do you express it, everybody? Yes, how do you express it? You express it as P total is equal to PA plus PB, right? Which can be written as, everybody, P total is equal to PA naught chi A plus PB naught chi B, right? You can further derive it and you can write it because we know that mole fraction chi A plus chi B is equal to 1. So we can also write it as chi A is equal to 1 minus chi B. Am I right, everybody? Are you listening to me? If you are, that means that P total is equal to PA naught minus PB naught chi A multiplied with chi A plus PB naught. Yes, this is how it is going to be written. Now you're going to ask me that, ma'am, what is PA naught? PA naught, my dear bachus, can you tell me? Is there anybody who can tell me what is PA naught? PA naught is the vapor pressure of pure solvent A and B, isn't it? And what is chi, guys? What is chi? Chi is equal to mole fraction of A and B in solution. Yes, what is it? Mole fraction of A and B in solution. Mole fraction of A and B in solution. Am I right, everybody? Yes, very good, very good, very good. Chi is this. This is how you donate mole fraction. Yes, it is written as X but pronounced as CHI chi. Very good. Ram, Satya hai. I do not know how your exam is going to go. Tomorrow is, in 4 days you have your exam and you are asking me, ma'am, what is chi? Class 11th you did not study. You skipped it. Huh? You skipped class 11 or what? Huh? Chalo. All right. Yes. All right. Yes, guys. So this is your Raoult's law, everybody. Have a look at it, guys. This is your Raoult's law, everyone. This is your Raoult's law. The whole page is right here in front of you, everybody. Cool? Yes? All right. Okay? No, you have studied it as X. I do not know who taught you as X, but it is actually Chi. It is actually Chi, okay? All right. When to use M is equal to N by N formula? When you are given normality and number of moles, but you do not know what is molarity. At that point of time, you will use that, okay? All right. Memory loss problem. Looks like it. Looks absolutely like it. Okay? All right, guys. Now, if in case they want to ask you, if in case they are asking you, 1 second, I need more pages. Just a second, guys. Yes, I needed more pages. Here we go. Now, once this is done, then we come across mole fraction in vapor phase. Okay, mole fraction in vapor phase. How do you write that? Mole fraction in vapor phase. Yes, so you will write it as YA is equal to PA divided by P total. And if it is about YB, okay, YB, that is component B, then you are going to write PB divided by P total. All right, that is it. Now, if we want to find out for a solution containing non-volatile solute, all these while that the formulas that we have written here, they were for two volatile components. Now, we are modifying the Raoult's law for a non-volatile solute. That means that there is a solution in which you have a non-volatile solute. So then what is it going to be? Then what is going to be the formula? So let's have a look at it, everybody. Let's have a look at it here. We're going to write it down. For solution containing non-volatile solute, everybody. For a solution containing non-volatile solute, what is it going to be? The P total will be written as P total. How can we write P total, guys? I have just told you. As per Raoult's law, what is P total? P total is going to be equal to PA naught chi A, isn't it? Yes. Plus, it is going to be PB naught chi B. Am I right? But tell me something. I've just told you non-volatile solute. That means this is not going to contribute towards the partial pressure. Am I right? This is not going to contribute. That means this whole term becomes 0. If this becomes 0, that means that my P total can be written as PA naught chi A. This becomes our formula. Agreed? Agreed or not agreed, guys? Yes. Agreed or not agreed? Agreed or not agreed, guys? Yes. Is this clear? Is this clear? Is this clear? Yes. 1 second, guys. Yes? All right. This is clear, guys? This is clear? How did that cancel? Baba. Oi. Why pitti khaoge yaar tum log? What are you guys doing? What are you guys doing? Huh? You guys want to get beaten up or what? Virtual punch and all you want? Huh? What are you guys asking? Ayyo. How did it get cancelled? It seems, bro. What is the heading? For solution containing non-volatile solute. Acha. Let's say that if I put some sugar in alcohol, the sugar is a non-volatile solute, isn't it? Is the sugar going to get converted into vapor? No. So is that going to contribute towards the partial pressure? No. No. Right? Alcohol is a volatile component. It will evaporate. It will get to its gaseous phase. But what about sugar? Is sugar going to get to its gaseous phase? If not, then will the vapor phase be able to exert some pressure on the liquid surface? No. That means 0, right? I will get tension with your exam. Now I will get stressed and I will not be able to sleep tomorrow. All these days I have been teaching and you guys are not learning. Why, my goodness. Oh my God. Chalo guys, moving on. Yes, moving on. Now, let us take a look at our colligative properties, everybody. We have 4 different types of colligative properties. We have relative lowering in vapor pressure, we have elevation in boiling point, we have depression in freezing point, and finally we have osmotic pressure. बच्चा ये what if मत करो अभी, है ना? क्लास 6 के बच्चे नहीं हो कि what if the sun did not rise, what if I did not sleep, what if there was no water, what if the sky was purple. Don't learn what I'm teaching you. Yeah, learn what I'm teaching you. Don't go there. Non-volatile solute, non-volatile solvent, this is how you write it. If the solvent is non-volatile, that means that Pa naught chi A is also going to be equal to 0. That means that P total is going to be equal to 0. What else? What are you asking? Okay guys, you know what? Let me do one thing. I'm not going to focus on the chat box at all, because I do not know where you have studied and what you have done with your all these days, what you have done with your days. But now it's time for us to study, focus up and study. So I'm going to go full on with Josh, okay? Because there are other students who are, because there are other students who are here to study. Okay? So sure, let us go ahead guys. Next, we are moving into colligative properties, everybody. Yes, colligative properties. So what is colligative properties? First one I told you is the relative lowering in vapor pressure. It is also called as RLVP. That is relative lowering in vapor pressure. All right, this is your first colligative property, guys. This is your first colligative property. So how do you write it? You write it as P total is equal to Pa naught chi A. Now chi A can also be written as Pa naught 1 minus chi B. All right, and chi B is equal to one second. Chi B can be written as here Pa naught minus P total divided by Pa naught. Now what is Pa naught? Guys, this, my dear student, is your relative lowering in vapor pressure. Alright, this, my dear student, is your relative lowering in vapor pressure. Relative lowering in vapor pressure, or I am just going to write it as RLVP. Alright, this is your relative lowering in vapor pressure. Cool. Alright. Okay. Yes. Moving on to the next one, guys. Moving on to the next one. Your next one, everybody, is elevation in boiling point. Okay. Elevation in boiling point. What happens is, this is directly proportional to the molality. So let us write it down, everybody. Let us write it down. Here, what do you have? You have elevation in boiling point. Elevation in boiling point, my dear student. This can be written as, everybody, delta TB is equal to KB multiplied with M. Here KB is the molal elevation constant. Yes, what is it called as? Molal elevation constant, or you must have heard it, abelioscopic constant. Abelioscopic constant. Okay, abelioscopic constant. Now let's take a look at the graph also, everybody. Yes, so if I want to draw the graph between vapor pressure and temperature, let's say that x-axis is temperature and y-axis is your vapor pressure here, then what happens is, for pure solvent you will get a graph like this. Yes, and for your solution the graph will somewhat look like this. Yes, now what happens is, if we draw a straight line like this, okay, if we draw a straight line like this and like this, then what will we get here? This will be your TB naught and this will be TB. This is the delta TB, guys. This is the delta TB. This is the elevation in boiling point, everybody. So this is your pure solvent. This is your pure solvent and this is your solution. So what do you observe? You observe that when you have added a solute in a solution, then the boiling point arises. That means the boiling point increases. The boiling point goes higher and higher up. And the difference in the temperature, that is called as delta TB. Am I clear, everybody? Yes, that is called as delta TB. Now, if in case in the question you are not given this molar elevation constant, usually it is given in the question. When we practice the question tomorrow, you will actually be able to see it. All right, yes, you will actually be able to see it tomorrow when we practice the question. But by chance, if KB is not given, then how can we calculate KB? Then we can calculate KB as equal to capital R multiplied with TB square divided by 1000 multiplied with LV. What is LV? My dear student, LV is not Louis Vuitton. LV is your latent heat of vaporization. LV is latent heat of vaporization. So this is how you can calculate your KB. This is how you can calculate your KB. All right, everybody, done deal. Yes, is this clear? Great. Moving on. Now we are going to study, everybody, depression in freezing point. Everybody, let us have a look at it. Okay, depression in freezing point. Here we go, guys. Here we go. Here we go. Here we have now depression in freezing point. Chalo, writing it down. Depression in freezing point. Okay, this is the third colligative property, everybody, and after this we only have one colligative property, that is our osmotic pressure. Okay, all right, that is our osmotic pressure. We will do that as well. Now, how do you write depression in freezing point? You write it, you express it as delta TF is equal to KF multiplied with small letter m. What is m here? M is molality. And what is KF here? KF is your molar depression constant, or we also like to call it as cryoscopic constant. What do we call it? We also like to call it as cryoscopic constant, everybody. Okay? All right, everybody. Yes. All right. So delta TF is equal to KF multiplied with M. Here KF is the molar depression constant. Writing it down, guys. Writing it down. Molar depression constant. Okay? And if KF is not given in the question, then you can calculate KF as RTF square divided by 1000 multiplied with LF. Here LF is the latent heat of fusion. What is it? Latent heat of fusion. All right, everybody. Now, if we are asked to make the graph, then the graph is going to look like this. Okay, so here it will be temperature, here it will be vapor pressure. Okay, so you notice that for the solution the graph is here. All right, for the solution the graph is here, but for the pure solvent the graph is somewhere here like this. Okay, so what happens here is this somehow gets connected here, and this is what you get. Okay, this is what you get here. This is your TF and this is your TF not. All right, so that means that this is for pure solvent, this is for pure solvent, the graph for pure solvent, and this is for solution. So we observe that in case of solution the freezing point decreases. Okay, the freezing point decreases. All right, yes. Now finally we are going to talk about the last but not the least, that is your osmotic pressure. What is osmotic pressure? The pressure applied to stop the osmosis. That is your osmotic pressure, isn't it? And how do we calculate osmotic pressure? We calculate it as pi is equal to capital C, capital R, capital T, where C is your molarity, everybody. C is your molarity. Capital R here is the gas constant, as everybody knows. Yes, and temperature is T, everyone. All right. Yes, guys. All right. Yes, this is the answer. Okay, this is the answer. All right. Yes. Now, moving on from here, everybody, let us have a look at your Van 't Hoff factor. Okay, your final topic for this lesson is Van 't Hoff factor, guys. Van 't Hoff factor. Here you go, everybody. Okay, how do you write Van 't Hoff factor? You write it as PA naught minus P divided by PA naught is equal to I chi B. I is the Van 't Hoff factor, everybody, and I will tell you how to calculate I as well. Okay? Now, when you write for delta TB, it will become I multiplied with KB multiplied with small letter m. Okay? If you want to write for delta TF, then it is going to be I multiplied with KF multiplied with m. Alright? If you want to write for osmotic pressure, it is going to be I multiplied with C multiplied with R multiplied with T. Now the question comes that, ma'am, what really is I? I can be written as, my dear students, I can be written as, everybody, writing it down here. Please have a look, everybody. I is equal to normal molar mass divided by abnormal molar mass, okay, abnormal molar mass, or you can write it as observed colligative property divided by calculated colligative property. All right, if that is not the case, then you can also write it as a total number of moles after dissociation or association divided by total number of moles before, okay, total number of moles before dissociation or association. Am I clear, everybody? Yes, am I clear? Now, for dissociation and association, I can be written as, for dissociation, we can write it as, everybody, yes, we can write it as I is equal to 1 plus n minus 1 alpha, where alpha is the degree of dissociation or association, and n is the number of moles that are dissociating or associating. All right, and for association, everybody, right here, everyone, check it out. I can be written as 1 plus 1 divided by n minus 1 alpha. All right, once again, everybody, reiterating, what is alpha? Alpha is the degree of dissociation or association. What is n? N is the number of moles that are dissociating or associating. All right, everybody. Yes, guys, is this clear to you all? What is abnormal molar mass? Very good, bacha. All right. Now, here are all the typed out. Yes, the typed out formulas are also here. If you want to, if you feel like reading a little bit more, then please go through it. You will find all the formulas here. These are typed out. If you find difficulties in understanding my handwriting, then also please go through the typed out formula. All right, everybody. Yes, guys, is this clear? Shall we move on towards the next chapter, that is electrochemistry? Okay. Shall we go and take a look at electrochemistry, everybody? Shall we? Shall we, guys? Are we done? Are baba, session PDF. Yes, guys, shall we go ahead? Yes? Very good. Chalo. All right. Now, let us start with electrochemistry, and the first couple of formulas that we are going to talk about, they are going to be about the electrochemical cell. Electrochemical cell, you know? Do you know what is electrochemical cell, guys? Do you remember that there was a container where there was a zinc rod dipped? There was another container where there was a copper rod dipped, right? And the electrons were moving from the zinc rod to the copper rod, and then copper was grabbing the electrons and it was forming copper solid, and zinc was giving away to electron and it was forming Zn2 plus. Do you remember, guys? Do you remember all of these, everybody? Yes or no? Yes or no? Yes or no, everyone? Yes. Yes, great, awesome, thank you so much. All right, yes. How to find negative deviation and positive deviation? Candyman, all of it is right here. See, ideal solution. What are ideal solution? Those which follow the Raoult's law. What are non-ideal solution? Those which do not follow the Raoult's law. Now, for positive deviation, what will happen? The partial pressure of each component A and B is going to be higher than the calculated ones from Raoult's law. That's how you will find out that this is positive deviation. If it is negative deviation, you will find out that each component, partial pressure of each component A and B will be lower than the calculated Raoult's law, and that's how you will figure it out that this is negative deviation. All right, done, guys. Done? Got it? Clear? Yes, Annie, absolutely right. So we are talking about Electrochemical cell. In case of an electrochemical cell, what is the first formula that we figure out? The first formula is, guys, E cell, that is E naught cell is equal to E naught cathode minus E naught anode. Now, according to IUPAC convention, what do we take? We take always the reduction potential. No doubt about that. I hope so. Yes, I hope there is no doubt about that. Yes, very good. Okay. Now, E naught cell, this can also be written as delta G naught is equal to minus NF E naught cell. Am I right? And we also know that delta G naught is equal to minus RT ln of KEQ. Is that right, guys? These are the formulas that we know. Now, these formulas, they are applicable whenever you have standard. Everything is in standard case. That's when we use this formula. Okay, but if things are not in the standard quantity, then what do we do? If the things are, if all the values that are given to you, they're not standard, then what do? Then you are going to use the one and only most popular formula, that, my dear student, is your Nernst equation. I have no idea why this equation exists. It should not exist, because I find this equation to be very, very weird. But any which ways, let me tell you guys. Let us suppose that we have a general equation, that is AA. And let's say that this is in aqueous phase, plus we have, let's say, B, capital B. And let's say that this is in gaseous phase. Okay, this forms C, capital C. And let's say that this is in aqueous phase, plus D, capital D. And this is in solid phase. Now, how do you want to write the E cell, guys? How will you write the formula for E cell? The E cell formula will become E naught cell minus 0.059 divided by N. What is N? Number of electrons. I hope you remember. Number of electrons that are participating in the give and take, right? Then you take log of Q is equal to, now see, D is solid, so we are not mentioning D at all. Here what we will do is, we will write C raised to the power C, then A raised to the power A. But do you see that B is in gaseous phase? If it is in gaseous phase, then we handle with pressure. We handle it with pressure. So here you will write PB raised to the power B. Do you guys understand? This is your Nernst equation. Okay. Alright. This is your Nernst equation. What to explain there, bacha? What to explain there? Guys, come on. Yeah, this is a formula. Revision. What are you doing? What are you doing? How hard is it to understand, everybody? Once again, letting you all know that this is a formula sheet revision. I am explaining wherever I can. Tomorrow, when we take care of the problems as well as we do marathon and we learn about everything, that time you will understand where and all to apply the formula. Can you please revise, bache? Can you please revise? And you tell me what is there to explain here. Delta G naught is equal to minus R minus T. Minus R multiplied with T. What is R? R is universal gas constant. What is T? T is temperature in Kelvin. You have taken KEQ and you have taken natural log here. That's it. ln of KEQ, equilibrium constant. KEQ is equilibrium constant. And you have used ln, natural log. That's it. Anything else? Anything else? There is nothing. There is nothing. Chemistry exam looks a little tough now. Your questions are very interesting. Candyman is asking how to find loss and gain of electrons. Really? Really? It looks like tomorrow when I take marathon, I might have to teach you from the very basic, huh? Should we also do 11th portions tomorrow? Huh? Kya re? Should we also study 11th portions tomorrow? Because doesn't look like you know your basics. How to find loss and gain of electrons, somebody is asking. Kya re? Redox reactions you have forgotten. Red cat, anox. What happens when Zn gives away 2 electron? What happens? It becomes Zn2 plus. What is this? Loss of 2 electrons. How are you finding that this is loss of 2 electrons? You can see the chemical equation and find out. No. Or no, you cannot. Huh? Kya re bacha? Candyman? Can you not look at the balanced chemical equation and find out where gain is happening, loss is happening? Don't you know oxidation is loss of electrons and reduction is gain of electron? We do not know that. Huh? Don't we know that? My God, my God, my God. What are you guys doing? What are you guys doing, Re Baba? Huh? Wow. Yes, Prabhu, they will usually give you the, constant values. Yes. Ideally, they should give. If not, we will tell you. Don't worry about it. Okay? Alright, so this is your Nernst equation. Now, at equilibrium, yes, dekho. Somebody is telling me Kc is only for equilibrium constant, no? Capital K is your equilibrium constant, okay? Capital K is your equilibrium constant. Cool? Alright. Now, K can take different cases, okay? K can be expressed as different in different scenarios. You can write it as different things, okay? So what is Kc? What is Keq? The equilibrium constant Keq. It can take several different forms. Kc is when Keq, equilibrium constant, is expressed in molar concentration. That time we take it as Kc. What is Kp? When equilibrium constant is expressed as what? As what? Anybody in the chat box? Now can you tell me at least? Now can you please tell me, everybody? Can somebody please tell me now? What? You guys have forgotten everything. I'm so disappointed. So very disappointed, guys. Keq, this right here, Keq, that is the generic equilibrium constant, okay? Kc is only and only for solution. Alright, Kc is only and only for solution. Okay? Alright, ठीक है? Now do we understand? Now do we understand, guys? Now do we understand, guys? Keq can also be expressed as Kp. If and only if when we are using partial pressures, we will use Kp. ठीक है? Alright. I hope you understand, guys. It's going to be really difficult if you do not know about these things. Yes, partial pressure. Thank you, Reti. Thank you, Irfan. Thank you so much. Thank you so much. Tamara, thank you. Yes, guys, do we understand this? Great. Yes, Tanushri. Yes, very good. Shall we move ahead? Shall we move ahead? Shall we move ahead, guys? Okay, moving on. Somehow my phone is not working now. 1 second. Just a second, guys. Something has happened. All right. ठीक है. So yes, we were talking about Nernst equation. All right. Now by chance, let's say that this equation we have mentioned, okay? At equilibrium, what will happen, guys? At equilibrium, what will happen? Your E cell is going to be equal to 0 and your Q is going to be equal to Keq. All right? Yes. So that means our formula will become E0 cell is equal to 0.059 divided by N log KEQ. Make sense or nonsense, everybody? Make sense or nonsense, everyone? Yes? Make sense or nonsense, guys? Come on, quick, in the chat box, okay? Finally, we are going to move towards Faraday's law, everybody, okay? We are going to move towards Faraday's law, all right? Yes, here we have a, yes, here we have a plain page. All right, chalo guys, moving ahead, moving ahead, moving ahead. Chalo. So, Faraday's law, everyone. What does Faraday's law suggest, or what does it state? Okay, what does it state, everybody? Faraday's law. I'm not able to see the chat, guys. One second, something wrong has happened. Something is absolutely wrong. I'm not able to see your chat. Just give me 2 minutes. Let me fix it. Because then I will not able to understand if you have a doubt or not. Yes, can you guys write something? Thank you so much, Aditya. Thank you so much. Yes, I'm guessing this is fine. This is fine. Faraday states that, yes. So let us talk about the first law of Faraday. Yes, Faraday stated that the amount of substance deposited on electrode is directly proportional to quantity of electricity passed through the electrolyte, isn't it? So let's write that down here. Let's write that down. Amount of substance deposited on electrode is directly proportional to quantity of electricity passed through electrolyte. Okay, all right. So how can we write that, guys? How do we write the Faraday's law? How do we express mathematically the Faraday's law? Let us have a look at it, everybody. Yes, you can write it as W is directly proportional to Q. That means that here, if we remove the proportionality sign, that means that a proportionality constant will come, which means that W is equal to Z multiplied with Q here, right? That means that Z can be written as, everybody, equivalent weight divided by Faraday, that is F multiplied with I multiplied with T, which can be written as W is equal to MIT divided by N multiplied with F. This, my dear student, is your first law of Faraday. Yes, this is your first law of Faraday. Now let us quickly take a look at the second law, everybody, and what does the second law state? What does the second law suggest to us? The second law says that if the if the same amount, okay, if the same amount of electricity, if the same amount of electricity is passed through different electrolytes, yes, the masses of its deposited, okay, The masses of ions. The masses of ions. The masses of ions deposited at the electrons, at the, what am I writing? Why electrons? Electrodes. At the electrodes are directly proportional. Are directly proportional to their chemical equivalence. Alright, which can be written as W is directly proportional to equivalent weight. That means that W is directly proportional to capital M divided by N. That means that we can always write it as W1 N1 divided by M1 is equal to W2 N2 divided by M2. And this, my dear student, is your second law of Faraday. Okay, and finally we get up to the cell characteristics. Do you remember what are the cell characteristic, everyone? The cell characteristic: conductance, resistance, resistivity, conductivity. Yes, exactly. So the cell characteristics, everyone, are here. Okay, first one, guys, let us talk about resistance. What is resistance, guys? What is resistance? Resistance can be mentioned as capital R is equal to rho multiplied with L divided by A, and the unit here is ohm. Agreed, everybody? Yes? Agreed, guys? Very good. Now, let us go to resistivity. What is resistivity, my dear students? Resistivity can be derived from resistance, and we write it as rho is equal to capital R multiplied with A divided by L. That means this will be ohm to the power minus 1. This will be ohm centimeter. Am I right, everybody? Yes, that is correct. Now, then next we go to conductance, everybody. What is going to be our conductance, everyone? Conductance is capital G is equal to 1 divided by R. That means that this is going to be ohm to the power minus 1, or it can be written as Siemens. Okay, all right, that is the unit. Okay, that is the unit, everybody. Then we go to conductivity, my dear bachus. And what is conductivity? Conductivity, my dear students, are kappa. Kappa is equal to 1 divided by rho, which is Siemens centimeter to the power minus 1, or you can write it as kappa is equal to 1 divided by R multiplied with A, which can be written as G star divided by R. Now, what is G star? G star, this is your cell constant, everybody. This is your cell constant. And last but not the least, the last formula, everybody, is molar conductivity. But I need some more empty pages. Guys. 1 second. Here. Okay. The last one is your molar conductivity. Can somebody tell me what is molar conductivity? What is molar conductivity, guys? What is molar conductivity? Molar conductivity is right here, everybody. Molar conductivity is equal to lambda m to the power c is equal to kappa multiplied with 1000 divided by capital M, molarity. And the unit is Siemens centimeter square mole to the power minus 1. Now, some of the students are asking, ma'am, please tell us the formula for specific conductance. Please tell her. So here it is. Conductance, specific conductance, molar conductance, equivalent conductance. All the formula are here. All the formulas are here, everybody. You need not worry about it. It is right here. You will get it. Don't worry about it. Yes, take a chill pill. I'm writing all the major, most important formula from where you can even derive the other formulas that if you want, you can do it. Okay? Now, guys, if we want to draw a graph, okay, what if we want to draw a graph and the graph has to be variation of molar conductivity with concentration? Then what are we going to do? We are also going to get an equation called Onsager equation, isn't it? We are also going to get Onsager equation. So let's have a look at that, everybody. Let's have a look at that. What is it? This is variation of molar conductivity, variation of molar conductivity with concentration. variation of molar conductivity with concentration here. This is how the graph will look like. First of all, everybody, yes, this is how it will look like. So you will draw it for delta C. Yes, root over C, and here you will have lambda m naught. How is it lambda m naught? Because everybody, you know what, let me not write lambda m naught right here. Okay, one second, give me a moment. This side on y-axis we are taking molar conductivity, so lambda mc. Now for a strong electrolyte, the graph looks like this because the graph actually cuts the y-axis. Wherever it cuts the y-axis, that is called as lambda m naught. But for a weak electrolyte, the graph kind of looks like this because it never cuts the y-axis. Okay, it never cuts the y-axis, everybody. Yes, now when we are talking about, so this graph, basically this graph is also somehow related to Kohlrausch's law, where we will come across in a while. But here you have to understand that from this graph, okay, or this graph, where did we draw this graph from? From Enseiger equation, okay, Enseiger equation, which is written as, my dear student, molar conductivity is equal to lambda m naught, that is limiting molar conductivity, minus, okay, minus, is that the one? And here A is the constant. Is that the one, guys? Are Baba, coming to Kohlrausch's law. Don't worry, I'll come to that. What is this? Huh? Why are you like so with this thing? Why are we actually taking root of concentration? Very good question. Keep finding it out. Okay. This is also called as Debye-Huckel-Enseiger law of strong electrolyte, isn't it? Yes. Yes, guys, or no? I am surprised by your doubts today. I'm really surprised by your doubts today. How are you guys asking all this question? It is absolutely, out of my mind. Like, seriously, how are you guys asking this kind of question? I have no idea how you are even getting there today, because it is, I mean, by now you should actually know everything, but you are asking such basic doubts today. But chalo, no worries. I really hope that this was a JEE English channel, so you probably know almost everything, but it's okay. No worries. Chalo, fine. No problem. Chalo. Now guys, let us have a look at Kohlrausch's law. Okay? This is, I think, the last topic. Last topic is Kohlrausch's law. Is there anything else? I don't think so. After Kohlrausch's law, there is nothing else. Right? That's the only thing. Chalo. So Kohlrausch, how do you spell it? R-A-U-S-C-H. Kohlrausch law. Don't make a spelling mistake, guys, okay? Do not make a spelling mistake. Kohlrausch's law is a little difficult to remember. The spelling is slightly different, but I guess that is how you spell it. Anyway, so what does it state? Kohlrausch's law states that at infinite dilution, what will happen? At infinite dilution, the molar conductance, okay? The molar conductance, everybody, the molar conductance of an electrolyte is the sum of molar conductances of its ions with molar conductance of each ion multiplied with the number of ions present in the formula of the electrolyte. Yes. So basically, what is it trying to say? Basically, if we want to express it mathematically, then suppose we have a compound which is AXBY format, okay? Then that means that it will become X A to the power X, not A to the power, XA. Here, this will be for the cation, Y plus, and then we can write it as YBX minus. Alright, now what we can write is lambda m naught AXBY. We want to find the limiting molar conductivity, isn't it? So that will be equal to X dot lambda m naught AY plus Y dot lambda m naught B X to the power X minus. Okay? This is how you write it. This is how you write the Kovalacz's law. This is how you express the Kovalacz's law. Alright. Now what is the application? Suppose you have a very weak acid such as acetic acid. Suppose you have acetic acid. How will you find the acetic acid? How will you find the lambda m naught for acetic acid? Very simple, very easy. But before that, let me write down the formula for application here, okay? Formula for application. You can easily calculate alpha also, by the way, from here, because lambda mc, that is molar conductivity, divided by lambda m naught will give you alpha. And you can calculate Ka as equal to C alpha square divided by 1 minus alpha. Now suppose you want to calculate the limiting molar conductivity of acetic acid, then you will calculate it as lambda m naught CH3COOH is equal to, it is going to be equal to lambda m naught, let's write CH3COONA plus lambda m naught HCl minus lambda m naught NaCl. Can we write it like this? Yes, this is the example. All right, this is the example, everybody. Are we done with this note? We are done with our electrochemistry chapter as well. Okay, as well, everybody. Are we done, guys? Yes. Are we done, guys? Yes. Yes, yes, yes or no? Everybody, are we clear with all of these? Are we clear with all of these, guys? And apart from that, if there is any other formula that you want, then right here you have the symbol unit, the specific, change with concentration, all of it is there. If you want me, I can also jot down some more formulas and give it to you in the chat box. All right. Yes. What is happening, guys? What is happening here? What is this? Thank you so much, Abhishek. Thank you so much for supporting me. And yes, I can see that there is one student who is behaving like a nuisance and he thinks that he will get footage from me. But guess what? Guess what? When you walk on a lane, there are a lot of dash who are barking. As a human being, we don't pay attention to all of those dashes who are barking, isn't it? Yes, and whatever he is asking, I think his mom can show it to him better because she is the one who gave birth to him, right? Go and ask your mom, bacha. Go and ask your mom. Maybe. Hanji, I will not take your name because you will get footage. I'm telling you, no. अपने माँ से जाके पूछो, जरूर पता चलेगा. मम्मी से जाके पूछो बच्चा. मम्मी से जाके पूछो, बता देगी, वो बता देगी. उन्होंने जो आपको पैदा किया है ना, उतने में ही निकल गया. लाइव रिप्रोडक्शन वही था. उनसे जाके पूछो, वो बता देंगे. Anyway, yes. Chalo guys, moving on to chemical kinetics. Are we ready, everybody? Chemical kinetics, everybody. Are we ready? Yes, yes, yes. Chalo. So chemical kinetics mein the first formula that we have to learn about is average rate. Okay, is average rate. So let us suppose that we have an equation which is AA plus BB gives you CC plus DD, isn't it? Yes, yes, yes. Very good. So this is our, let's say that this is our general equation, some general equation that we are taking right now. Okay. Now when we take this, so how do we write the average rate, everybody? The average rate is going to be equal to minus 1 by A, delta A divided by delta T. Guys, one second. Now my delta and A looks very similar. So I'm going to just change it. So this is our delta, this is our delta, and this is our delta T. Do you notice that here I have mentioned minus sign. Why have I mentioned minus sign, guys? Why have I mentioned minus sign? That's because the reactants are decreasing. The reactants are decreasing, isn't it? Acha, tabi, that's why. Abhishek, now do you understand why is he behaving like this? Tabi. There is a lack of a motherly figure in your house. That is why you're behaving like this in the class. So you know what? You must have some women in your life, in your house, isn't it? Sister, aunt, mother, grandmother, somebody. Ask them. Okay? Don't behave like this in our class, because then you are showing that what is your parvarish. समझते हो? आपकी अपब्रिंगिंग कैसे हुई ना, वो यहीं पे दर्शा रहे हो आप. और अलोन हो तो बहुत बढ़िया, फिर सीखना ही है. सीखना ही क्यों है? सीख के करोगे क्या उसका? जब अकेले हो तो अकेले ही रहो, सिंगल ही ठीक है. क्या करोगे सीख के? जो आप पूछ रहे थे उसका वो सीख के करोगे क्या? अकेले तो हो आप. Anyway, guys, disappearance. Very good. Vitesh, very, very, very good. Absolutely. Absolutely. Disappearance. Rate of disappearance. Yes. Of the reactants. Because if the reactants disappear, only then the products are going to appear. Right? So then we are going to write here minus 1 by B multiplied with delta B divided by delta T, which is equal to plus 1 by C here, and delta C divided by delta T is equal to plus 1 divided by D delta D divided by delta T. So these two, my dear students, what are these? These are rate of disappearance. Yes, these are rate of disappearance. Okay, these are rate of disappearance. And what are these? These are rate of appearances. Rate of appearance. Okay, these are rate of appearance. Now what is the unit, guys? You can write the unit. Okay, by chance if there are gases, then the unit is going to be ATM S to the power minus 1. And if this is how they are given for solutions, then you're going to write it as mole L to the power minus 1 S to the power minus 1. Am I clear, everybody? Yes, 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 yes. Jivadarshani, I will give it to you. Don't worry, I will give it to you. I'll get it for you. Okay? All right, guys. Okay? Yes? Okay. Moving on. Now let us talk about rate laws, everybody. Okay? Now let us talk about rate laws. But once again, I will need pages. What is this going on here? Where are my pages? Just a second, guys. Need more pages here. Ha. Okay. Now what are we going to do, guys? We are going to take a look at rate law. Yes, we are going to take a look at rate law. Yes, so how do we write the rate law, guys? We write it as rate is directly proportional to A to the power M, B to the power N. Now that means that to remove this proportionality sign, we will need a constant. And that becomes rate is equal to K multiplied with A to the power M, B to the power N. What is K? K is your rate constant here. So let me write it down. K is your rate constant, everybody. K is your rate constant. What is M? M is the order with respect to. Order with respect to A. What is N? N is order with respect to B. And M plus N is your overall order. Yes. Acha, by the way, now do you think that M is equal to A and N is equal to B always? No. For elementary reactions, for the slowest step reaction and for single step reaction, M is equal to A and N is equal to B. Otherwise, not in every case, okay? Not in every case you will find that M is equal to A and B is equal to N, okay? Now we come across the integrated rate law, and for that, the first one will be zero order reactions. Shall we take a look at it? Let us take a look at it, everybody. So the first things first, here integrated, okay, integrated rate law, everybody. Here we have integrated rate law. Basically, first of all, let us do it for zero order reaction. What happens in a zero order reaction, guys? We know that the rate does not depend on concentration of reactants, isn't it? Rate does not depend on concentration of reactant. For a zero order reaction where reactants are getting converted to product, we write the rate is equal to Kr, isn't it? Yes, that is how we write it. That is how we write it, which means that rate is equal to the constant, that is K. And if we want to make the graph, then how the graph is going to look like, guys? The graph is going to look like, see, here we have concentration and here we have rate. So this is going to be your graph. It is going to be parallel to the y-axis, that is parallel to the concentration. So if we want to write another equation, let's say concentration at time t, if we want to find out, then that will be initial concentration minus kT. And for this, if we want to draw the graph, then it will look somewhat like this. Here is your time, here is your concentration at time t, and the graph, this will be negative slope, and this will become your CO, that is initial concentration. Am I clear, everybody? Are you guys understanding? Yes. Are you guys understanding, everybody? Yes, great. Now finally, what is the half-life for zero order reaction? The half-life for zero order reaction is initial concentration divided by 2K. That means for this also we have a graph, and that somehow looks like this, everybody. Here you have the initial concentration and here you have T half. So the graph looks like this. Is that right, everybody? Is that right, guys? Are we all understanding? Are we all understanding? Yes or no? Yes, we are. Okay, next one, guys. Next one. Everybody, please focus up. You guys are not focusing up. You guys are not focusing in the session, everybody. I need you all to focus up, please. Okay, now let us have a look at the first order reaction. Shall we, everybody? First order reaction. Are we here, guys? First order reaction. Chalo, let us take a look at first order reactions. So the first order reactions here are, everybody, yes, very good, Shahitika, very, very, very good, bacha. Absolutely right, okay? Yes, Abhishek, I did, because you will have Nandini ma'am, right? See, it was getting very difficult to teach all of it. I'm pretty sure that you must have seen that, you know, teaching physical and inorganic, there are too many chapters for class 11th and 12th. It gets very difficult, and I was not able to spend enough time on organic, because I feel like organic is a field in chemistry which requires time from the very beginning. So next year I'm planning to take up organic chemistry, but this year I could not. Hence, I have completely given it to Nandini ma'am. Okay? Next year we will try and see if I can take organic. Okay? Next year, but not this year. This year, like I said, organic takes a lot of time, and I would not have been able to justify to that work. That's why I gave it to Nandini ma'am. Okay, next year we will see. Chalo, guys. Okay, now here see, reactants to products are forming. Okay, here what happens is the rate in case of a first order reaction is directly proportional to the reactant's concentration. Now the moment I said that, you will be able to derive the rate, right? Rate is K multiplied with R. Here for R we write 1. That means that the graph is somewhat going to be like this. Do you agree, everyone? This will be concentration, this will be rate. For a first order reaction, this is going to be the graph. Am I right? Very good. Okay. Great. Now moving on, let's suppose that the concentration at time t, it will be CO e to the power minus kT. If that is the case, then how am I going to draw the graph? I am going to draw the graph, but I am going to draw the graph. How will it look like? How will it look like, guys? The graph, I suppose you will all agree with me that this is how it is going to look like, everybody. Yes, like this? No, I have not even drawn the graph. So this is going to be your CT. That means that there will be a curve like this, isn't it? This is how the graph is going to look like. Now, what if I take log on both the sides? Okay, if I take log on both the sides and if I then simplify it, then what happens? Then my equation becomes K is equal to 2.303 divided by T log CO divided by CT. Am I right? Yes. Now this CO divided by CT can also be written as A divided by A minus X, where A is your initial number of moles. What is it? Initial number of moles. And what is X here? X is your decrease in the number of moles. What is X? X is your decrease in the number of moles, my dear bachos. Okay, now you're going to ask me that now, ma'am, what is the half-life, everybody? Half-life for a first order reaction. Half-life of first order reaction is given as T half is equal to ln of 2 divided by K, which is basically 0.693 divided by K. That means that this is absolutely independent of the rate, absolutely independent of the concentration, isn't it? Yes, everybody, very good. So here, if I want to draw the graph for T half, then how is the graph going to look like? The graph is going to look like this. T half here, yes, this is our initial concentration CO. So the graph is going to be a straight line, which is nothing but 0.693 divided by K. This right here, guys, right here. Okay, and if I want to draw another graph, okay, one last graph, let's say that if I take natural log for the CT, concentration at time T and concentration initially, then how the graph is going to look like? Then the graph is going to look a little like this. Here is your time. Okay, one second, sorry, moving on. This is your ln of CT. That is what I've taken here, right? So that means that once again, this graph will also have a negative slope, and here ln of CO. This is your final graph here. Okay. Last but not the least that we have in this chapter is, everybody, your Arrhenius equation. Okay. What is it that we have? We have the last bit of the session, which is Arrhenius equation. Guys, are you all... What are pseudo-order reaction? The pseudo-order reaction and everything, guys, where we will do it, but we will do it tomorrow when we do the chapters in details. Okay. Today, right now, please have a look at the formulas and keep it with you. Then go and read the NCERT. Will you all do that to me, guys? Yes, I think I've given you the tasks. I do not know why you are not listening to the task. Right. So here, guys, moving on, let us now have a look at your Arrhenius equation. Okay. Arrhenius equation, the last bit of the chapter here. So the rate of reaction is related with temperature with the help of the Arrhenius equation, everybody. Okay. In case of Arrhenius reaction equation, what do? We relate temperature with rate of reaction. Okay. So here the formula is K is equal to AE to the power minus EA divided by RT. Let me write down what is what here. So K here is obviously your rate constant of reaction. Rate constant of reaction. What is A here? A is your Arrhenius constant. Yes, this is your Arrhenius constant, right? What is EA? EA is the activation energy. EA is the activation energy of reaction. Sorry. Am I right? Yes. What is R, guys? R here is the universal gas constant. Am I right? And what is T, guys? T obviously is your temperature that is expressed in your Kelvin. Now, by chance, let us suppose that you are given two temperature and you are given two constant. What are you going to do, guys? What are you going to do? Let us have a look at it. Chalo. Let us have a look at it here. Okay. Suppose that at temperature at temperature T1, a rate constant for you is K1, okay? And at temperature T2, rate constant is equal to K2. If that is the case, then how are you going to write? You're going to write it as log of K2 divided by K1 is equal to EA divided by 2.303 R multiplied with 1 divided by T1 minus 1 divided by T2. Am I right? This is how you're going to write it. This is how you're going to write it, okay? Now let us quickly look at the graphs, everybody. Let us quickly have a look at the graph, because now after that we are done. So graph, what is our equation? Our equation is, my dear student, K is equal to A e to the power minus EA divided by RT. If I take natural log on both the sides, that means it will become ln of K is equal to ln of AE minus EA divided by RT. This can be, correlated with y is equal to mx plus c. Can we do that? Yes. Can we do that? Ln is, y is equal to mx plus c. If that is the case, then my graph is going to look like how? My graph is going to look like this, I suppose you know. So we will be taking ln of k as y-axis. And here we will have what? Here we will have 1 divided by t, because EA divided by RT, right? So my slope is going to look like this. This is my slope. My slope is going to be minus EA divided by R. And this intercept will be ln of A, correct? Instead of taking natural log, what if we take log base 10? That means that our equation is going to look like that means that our equation is going to look like, have a look everybody. Have a look everybody. Here it will be K is equal to A e to the power minus EA divided by RT. This is the equation, isn't it? So if I take log here, it will be log of K is equal to log A E minus EA divided by 2.303 RT. Nothing will change. Only thing is your slope will become C. 1 second. This is going to be your graph, okay? This is going to be your graph. So here you will take 1 by t. Here you will take log of k. Yes, if you take log of k like this, that means your slope is going to be like this, which means that this is minus EA divided by 2.303 R, and this particular place is your log. This is your log of A. So that is the graph. These are the formulas. And everything is completed, guys. Apart from this, if you want to check out some more formulas, yes, for integrated rate law, half life, 3 by 4th life, all of it is written here, everybody, okay? All of it is written here. This is your Arrhenius equation. Everything is completed. So all the students who are asking that, ma'am, when will the class get over? When will the class get over? The class is about to get over. Now, how many of you want to take up a model question paper? How many of you want to actually go for a test series, guys? Do you guys want to give a test before your class 12 exam and see where you stand? If that is the case, then just below this video in the description box, you will find the link for the class 12 test series. Here CBT mode it is, board exam related and board's new syllabus. Apart from that, all your resources, guys, NCERT solutions are also in the description box just below this video. I will show it to you. And please don't forget to join the Telegram channel. The Telegram channel link is also right here, everybody. Chalo, let me show you guys. And I will also show you that right away. I'm going to send you I'm going to send you this video. 1 second, guys. 1 second. Where's our video? Chalo, we will search for it, okay? Searching for Vedantu J English channel. Search for it. This is our channel. Have a look at it, guys. Have a look at it. So I can see that so many of you are watching, and oh my God, crazy. Thank you so much. I have also liked my video, everybody. So now let me pause this. Okay, let me pause this and see. I will just click on this more. Do you see this more? Just click on this more. Right here, this side, everybody. Do you see? You can register for IVSAT, that is Vedantu Scholarship Admission Test. Instant Vedantu Scholarship Admission Test. Here is Vedantu Online Store, everybody. Right here is your Vedantu JE Telegram channel. So just go and click on this link and join it, everybody, because I am sending the note right away. See, sending it to you right now. Check it out. See, ye dekho. Going to Telegram. Just clicked on Telegram. Now here, do you see Vedantu JE English channel? Do you see here? Sending it to Vedantu JE English channel and sent. And sent, everybody. Alright. So you guys, I need you all to go and join the Telegram channel. And if you are not able to join the Telegram channel, no worries. Below this video, just after I finish the session, you will be able to see the PDF. You will be able to see the PDF. Pakka promise, ma kasam. Okay? Alright, with this note, everybody, I would like to say tara bye-bye. Thank you so much. Thank you so much. You guys have been great. You guys have been super supportive. I will see you tomorrow at 12 p.m. with an inorganic session. And tomorrow we will be completing our inorganic chemistry. We will also be completing physical chemistry in the evening. So be there. Stay tuned. And now after this class, your task is to go through the 20 name organic reactions. Apart from that, you are also going to go through this formula sheet, which I have already sent it in the Telegram channel. If you did not get it, no worries. It will be pasted just after this session in the description box. Apart from this, everybody, anything else that you require from us, do let us know in the comment section. We will try to help you with it as much as we can. Okay? Lots of love. All the very best. I'll see you tomorrow. Till then, tara bye-bye and study well. Okay? Study well. Be here but study well. I assume that you know certain things. You cannot ask me to teach from the basic. It's going to take a lot of time. Please understand it. Okay? So tara bye-bye. See you all tomorrow.